Everybody. Today we're going to learn about geometric sequences, and the key is just simply multiply, multiply, multiply. So a geometric sequence is any sequence where each term is multiplied by the same thing over and over and over again. We call that common ratio R. And so in this particular case, to go from 3 to 6 is a multiplication of 2. And if you notice, that pattern repeats in the next one too. 6 times 2 is 12, 12 times 2 is 24, and so forth. 2 is what we call the common ratio. The reason it's called a common ratio is because you can find it, if it's not so obvious, by taking one number and dividing by the number before it. So the ratio in this case would be 12 divided by 6, which of course is 2. And in the next one, the ratio would be 24 divided by 12, which of course is 2. So in this particular sequence, that ratio is not quite as obvious what it is. So to go from 180 to negative 120, the ratio is negative 120 divided by 180. That fraction reduces to 2/3, specifically negative 2/3. So that means if I were to take negative 120 and multiply it by negative 2/3, that will give me a positive 80. I want you to notice that if you've got a positive number and then a negative number and a positive number and then a negative number, then that must mean you have a negative ratio in your geometric sequence. Now, a geometric sequence can always be written using the geometric formula, which is that you take the first number in the list and you multiply it by the ratio raised to the n minus first power. I hope that this looks kind of familiar to you. It's very similar in what you need to the arithmetic sequence builder. Remember, you needed the first number in the list, and in that case, you needed the common difference. But here we need the common ratio. And instead of adding, you're multiplying each time. So here's an example. Let's look at the sequence 16, negative 8, 4, and so on. Let's see if we can figure out what the common ratio is and therefore what the next couple terms are and so forth. So to go from 16 to negative 8, that would be a ratio of negative 8 divided by 16. Negative 8 divided by 16 is the fraction negative 1/2. And so let's test that a second. If we were to take negative 8 and multiply it by negative 1/2, that should give us 4. So negative 8 times negative gives me positive again. 1/2 is like cutting it in half. Yeah, that gives me the 4. So the next number would be if I multiplied 4 by negative 1/2 again, which is the same thing as dividing by negative 2. That would give me a negative 2, and then positive 1 again, and back to a negative 1/2. All right, so now that we have the next couple numbers in our list, let's see if we can find the nth term in this sequence. I'll pull out the geometric formula builder here. And remember, in this first blank, we needed to put the first number, which is 16. And then in this ratio here, we have to write that ratio we had found earlier was a negative 1/2. And so here is a formula for the nth term in the sequence. We can use this formula then to find the 15th number in the sequence. And simply plug in a 15 for n and see what we get. If you do that on a calculator, negative 1/2 to the 15 minus 1 is negative, would be the 14th. You're going to get a pretty ugly decimal. And, that's okay. Sometimes you want a decimal. But if you want it exactly, if you want to write it as a fraction, you're going to have to be a little smarter about it. The fractions that you'll get this many terms in are probably too big for your calculator to be able to use the convert to fraction tool. And so here's how you could do that if you needed to find it exactly. Here's our formula, 16 times negative 1/2. And I put in the 15 in the case of n. And what we need to do is, we'll simplify this a bit. 15 minus 1 is 14. And then I'm going to split the negative and the 1 and the half as separate parts in this ratio. And so I'm going to write this as 16 times the negative part, so negative 1 to the 14th. And then the numerator was 1 to the 14th, and the denominator was 2 to the 14th. And we'll deal with each of those separately. The negative 1 to the 14th, that's a even number of negative ones. And so that part simply turns out to be a positive. And so what that means is that the 15th term is going to be a positive number. The 1 to the 14th is just 1. And so 16 times 1 times 1, that the numerator of this fraction is 16. And then 2 to the 14th is the number 16,384. And so here is the 15th term written as a fraction. And this can be reduced a little bit since they're each divisible by 2, actually a couple of times. You can divide them each by 16. This reduces to the fraction 1 over 1,024. One last question to answer here, and that is, where does 0.0001 fall in this list? And to be honest, I didn't think this one through to begin with, and so this number isn't going to fall in our list exactly, but we can see kind of in between what terms it would have fallen. And to do that, I think I'm going to write it out. I'm just going to keep going with these terms until I get to a number that's close to 0.001. But I'm not going to do that manually. I'm going to use a spreadsheet to make that happen. So here is a table, and let's fill it in with these numbers. I'm going to put a 16 in the first box. And while I could put in negative 8 and then in 4 and negative 2 and find each of those by hand, let's have the spreadsheet calculate it for us. And so to do that, what we have to do is use a formula. You'll type an equals sign, and then we'll click on this cell here. And I want to, every time I go forward in this process, I want to multiply by that common ratio, which was negative 1/2. So I'll write times negative 1 over 2 and hit enter. Notice it calculated a negative 8 for me. And I don't have to type that formula over and over and over again. Spreadsheets like Excel or table here in Keynote, you can drag this little box here, and that formula will drag with it and fill in all these different things. And so we can see, you know, here was 1, what's that fifth number in that list, and then negative 1/2 and positive 1/4. And it looks like 0.001 would have fallen somewhere around the 14th or 15th term, right? It's about that when we get into that size of number. So now it's your turn. Here's a sequence, 3, 12, 48, and so on. I'd like you to see if you can find the next 3 terms in the sequence and a formula for the nth term. Once you've done that, see if you can find the 15th term in the sequence. And then a little bonus question says, what are the last 2 digits of the 1000th term? And so good luck with that one. A little bit of a puzzle. I would encourage you to pause it now and come back in a little after you've had a go. All right, hope you've had a good chance to have a go at it. The first thing I noticed is that we're multiplying by 4 each time. And so to come up with the next numbers in the sequence, simply continue to multiply by 4. That should give us like 150 something. I'm going to use a table to find those numbers in a moment. The nth term in the sequence is simply the first number times 4 raised to the n minus 1. And so if you want to find the 15th number right away, you would do 3 times 4 to the 15 minus first calculator. That gives us this giant number. To answer this last question, what's the last 2 digits of a 1000th term? I hope you tried it on your calculator, but then realized there's no way you can calculate 3 times 4 to the 1000th power. That's way too big. It would give you an overflow error. Thankfully, we don't need to know that. We only care about the last 2 digits. And so there's a pretty common trick here. Let's take a look at some of these numbers and see if we can find a pattern. So here is a spreadsheet. We've got 3 filled in for this first one. And I'll go ahead and multiply that box by 4. And I'll take that formula and drag it down to all the other numbers here in the list. And if you look carefully at the last 2 digits each time, we've got a 12, 48, 92, 68, 72, 88, 52, 8, 32, 28, 12 again, 48 again, 92 again, 68 again, and so forth. In situations like this, there's a pattern. And in this case, the pattern is that those last two digits repeat every 10 terms. And so if we look, the 7th number in the list ends in an 88, and the 17th number in the list ends in an 88. And so the 1000th number is going to be a multiple of 10, and so it ends in the same thing that 10 or 20s ends with. And so the final answer there for the last two digits, that would be a 32. That concludes our video on geometric sequences. Be sure to come back for the next one when we start thinking about adding these all up, called geometric series. See you then.